our next presenter today is Dan Kelting, and he is the Executive Director of the Paul Smith College Adirondack Watershed Institute. Dan received his PhD in forest soils from Virginia Tech in 1999, and his research areas include nutrient cycling, aquatic invasive species, and effects of multiple stressors on terrestrial and aquatic ecosystems. He's been working in the Adirondacks for the last 14 years, where he has used scientific information to inform and engage multiple stakeholders on environmental issues, most notably road salt. His efforts in this regard have been formally recognized by the Adirondack Lakes Alliance, the Adirondack Park Agency, and the Upper Saranac Foundation. And Dan's going to be presenting today on road salt reduction initiatives in the Adirondacks. So thank you, Dan.
How's that? Yeah, it feels all right. A little bit weird, but am I on? This is a strange experience. Not sure if I should sing or land airplanes. I'm not really sure. Well, good morning, everyone. I'm going to say congratulations to the Cary Institute right off the bat. This is quite a turnout for a meeting. We've had several of these kinds of meetings up in the Adirondacks over the last close to a decade now, and we've had some pretty good turnout, certainly, but this is a really great turnout, so congratulations. So I will be talking about road salt reduction initiatives in the Adirondack Park, and I'm going to really be focusing on a lot of local initiatives. I will touch on some regional initiatives, which are mainly in the outreach domain, and I know Mike Lashman is going to be talking about work at the DOT. Certainly that dovetails nicely in terms of regional effects. I'm going to start out sharing with you some of the kind of the high-level results in terms of what we know about salinization of Adirondack waters to set the stage for what we're doing about that. So you'll see some commonalities with what Stuart has presented for down here. I'll start off with my take-home messages, and first, as we use a lot of salt, like here that Stuart pointed out, there's really a lot of interest in reducing salt use, not only by environmentalists, if you want to call folks environmentalists, but also certainly by municipalities, practitioners, all folks across the board are interested in reducing salt use. There are a number of initiatives underway, so there's a lot going on, and I'll just highlight kind of the key ones for you today. And then the last point is, or take home is, if we want to achieve regional reduction in salinization of water, surface water, groundwater, all the initiatives need to be coordinated and supported. So that'll be my last message. So I didn't make a state map showing where the park is. Hopefully you all know where the Adirondack Park is. It's a big blob up north of here. Takes a couple hours to get there. Big green blob. So about 6 million acres. We all know the story. So the park has just under 11,000 lane miles of paved roads. This is a combination of state roads and local roads. So the state roads are shown on here in red, 2,830 lane miles. This would be our state highways, our U.S. route, and our one lone interstate. And then we have 7,725 lane miles of local roads. These are town roads, county roads, and what are called local roads in the park. On an annual basis, our state roads receive, on average, about 108,000 tons of salt, while our local roads receive about 85,000 tons of road salt. You'll notice that even though the state roads are roughly a third the lane miles of the local roads, they receive much more salt. And this really has to do with the differences in how these roads are managed. All state roads are salted with high amounts of road salt, while local roads receive, some are just plowed, some are plowed and sanded with varying amounts of salt, and some are actually plowed and salted following the state DOT method. So there's a lot of variation, excuse me, in how local roads are treated versus the state roads. And that's important when we think about later about how we're going to manage salinization at the regional scale, given that there's such a difference and how our roads are managed. So if we look at this total salt load annually, if we add all this up over time, the sort of legend, the lore in the Adirondacks is that wide-scale use of road salting started around 1980. So our second Winter Olympics in the Adirondacks. So if we total all that up, have just under 7 million tons of salt applied to our roads since 1980. This is a remarkable number. This is actually would represent the largest import of any pollutant into the region, actually double what's happened over that time period in acid deposition in that region. But one of the differences, though, this is put on roads. So it's nearly 7 million tons of salt put on a very small area of land. So it's a big input, and I know there were a lot of questions about, where does the salt go? And if you read the literature, a pretty good rule of thumb is about 50% of the salt would run off as direct runoff, so about 3.5 million tons or so would be going right into the streams and the lakes, eventually making out into the rivers, into the ocean. And the other half would infiltrate into the soil, where some of it would be retained in the soil, perhaps on exchange and micropores, and some of the remainder would make it down into groundwater, and of course some of that would be making it into surface water, and some would be building up. We've also done an analysis. We developed a GIS model, so geographic information systems, just using topography to route road runoff. And so the thinking here is the road runoff has salt in it, and what's the connection between that road runoff and surface water? And you can see here, is this a dot? Oh, okay. I thought it was going to be red. I saw green. I wasn't sure. Green meant on for me. Anyway, so 6,000 miles of streams in red. About 52% of the total stream length in the Adirondacks receives runoff from paved roads. About 195,000 of acres of lakes in red. 77% of the total acres, 820 water bodies. Depending on what metric you use in the Adirondacks for water bodies, it's anywhere between 3,000 and 30,000 lakes. So I can't give you a good percentage on that one. But a large percentage of water bodies, both streams and lakes, are receiving runoff. So there's a high degree, a high potential for regional salinization of our water. So that's sort of the background. What do we know? And I'll just quickly show you a couple of high-level results. This map shows, we put together a data set back in around 2010 or so. We have lakes and watersheds without paved roads shown in blue, lakes and watersheds with paved roads shown in red. And here we just look at the median chloride concentrations. You can see this is parts per million or milligrams per liter, as Stuart was showing in his slides, same unit essentially. And so lakes and watersheds with no paved roads, there's 56 lakes. Our median is less than 0.5 parts per million, so Stuart's is 10, ours is 0.5. Why so much lower? The big difference in geology, I think, might explain that. We have a lot of igneous rock, low chloride-bearing rock. I think you have a lot more shale and slate sedimentary rocks down here, have more chloride in them. So we have a much lower baseline chloride in the Adirondack waters, and we have about 14 times higher chloride concentration in lakes and watersheds with paved roads. So the median is just over 6 versus under 0.5. So on Stuart's graphic, we're green, right? We're green based on Stuart's rules of thumb. So, but you can see there's a lot of variability there. So that's the median. This is a 95% confidence interval on the median. So what explains this, or what contributes to explaining this variability in chloride concentration? And what we look at road density, and we found that, so we're looking at chloride concentration on the Y and the density of state roads and lane miles per square mile watershed area on the X. We can see that state road density explains 84% of the variation in chloride ion concentration. So a very strong positive relationship there. And really, the higher the density, the higher the load. So the road density is just a surrogate for salt load. Remember, all state roads receive high and similar doses or loads of road salt. Equally important is we found no relationship between chloride concentration in local road density. So if I put the local on here, it's a shotgun blast. This goes back to my point in the beginning is all state roads are treated the same. Local roads are treated all different ways, so there's not a consistent relationship there for local roads while there is for state. So our conclusion here is that regional salinization, when we look at the park, is largely attributed to salting of state roads. So at the regional scale, we need to focus a lot of effort on what's happening at the state level, or on the state highways. All right, let's talk about some local initiatives, and then I'll talk about some state. So I'm going to talk about what we call smart salting. It's a version that's sort of like precision agriculture or precision forestry. Precision salting is a term that's used in Europe. But I'm going to talk about a couple of things, very specific things: live edge plows, brine, and optimization. Then we're going to touch on the use of abrasives, which are coming back again. This is interesting. And then remind us about sidewalks and parking lots, which are can be very important depending on where you are in your particular watershed, even in the Adirondacks. And I'm going to draw heavily from experiences in Lake George, which has really been a leader in helping to develop some of these technologies and integrating things together for reducing impacts of road salt on the waters in the Lake George Basin. And then I'm going to also be referencing Lake Placid, which is like Little Lake George in the northern Adirondacks. All right, so first I want to start off with Stuart mentioned practitioners. There's no bad, there's no good, there's no bad. And I spent a lot of time talking to practitioners. I wanted to give you a couple of quotes from a couple of folks I was talking to on the phone last week, because I think this illustrates this well. So this is Tracy Eldridge. She's the highway superintendent for Hamilton County, that's shaded in blue there. And so this is Tracy, direct quote from Tracy as we're on the phone. I think I got it pretty well. So highway departments don't like salt either. So it destroys our bridges, roads, and trucks, and we care about the environment too, right? So they also care about the environment. And they're also on the front lines, and public safety is our primary responsibility. So they have a conflict, right? So they care about salt just like we do, but they also have the charge of maintaining the safety of the roads. We go to bed at night assuming we can drive to work. They go to bed at night worrying about the conditions of the road. So it's different. He goes on to say that many things can be done to reduce road salt, and they know that, but largely because of concerns about public safety, they feel inhibited from doing a lot of other things. And a lot of that has to do with concerns about lawsuits. So what Tracy, his final comment to me was the state legislature needs to be engaged to address our concerns related to safety and lawsuits. And this is a reoccurring theme that I get when I talk to local government with highway superintendents, is that they feel somewhat tied, their hands are tied to what they're doing now because they're concerned about liability. And so that's a huge issue. It's not a theme of my talk, but this is something that has to be addressed if we want to start to consider other options for treating our roads. Another quote from Warren County with Bill Lamy, who's the superintendent of public works for Warren County. And so Bill goes around and visits with all the superintendents, and one of the first questions he asks them is, do you have a written plan for winter road management? He said, well, some don't. So there's a starting point. So Bill says, some highway departments don't have a written plan. I tell them to put their plan to paper. And so in his plan, he tells them they should be efficient, smart, and take measurements. So these are all elements of a plan, right? Generic elements of any good management plan would be efficient, smart, and taking measurements. So Bill, within Warren County, also working with the Fund for Lake George, Waterkeeper, are working actually quite proactively to develop road salt management plans within their county. So that's very encouraging and direct evidence of folks trying to do the right thing. So now let's talk about, so Bill kind of introduced this idea of smart salting, right? So be smart. So what is smart salting? Well, it's really three things. Apply road salt in the right amounts, in the right places, at the right times. That's what it comes down to. And there are several things to consider when we're thinking about smart salting. First is what is the level of service trying to be maintained for that particular roadway? What types of equipment are needed, or what types of equipment are available? What type of salt are you using? So is it road salt? Is it some kind of blend? Is it some treated salt? How is the salt being applied? Is it as a brine? Is it a solid, etc.? What are the weather conditions? What's the temperature? What's the storm severity, duration? All of these things go into developing a plan using smart salting concepts. And our best example of applying this idea, this concept, happens with Lake George. And so here's our Lake George Basin, and my friend Chris Nowitzki sitting over there. Hey, Chris, raise your hand. Chris. So Chris is one of my partners in road salt work, and his group, the Fund for Lake George, has funded and supported Chris's initiatives and others related to road salt reduction work within their basin. So they have developed a lot of ideas and implemented them on the ground within their basin to reduce salt use while also maintaining public safety. So one of the first things I want to talk about a little bit is what's called the live edge plow. Who's heard of a live edge plow? So, not very many. Anybody use one? You've heard of it and use it. That's good. So the live edge plow is a really neat device. I was introduced to it at a conference that was at the salt conference that was hosted by the Fund for Lake George. This was about 3 years ago, I think. And so what you're looking at here, so a standard plow has a rigid blade. Live edge plow, the blade is actually segmented. And so what you can see here, we'll look at the one on the right, you can see the segmented blade actually follows the contour of the road. You can see it quite well there, and then you can see it well here, where most of our roads have a little divot, right, where the tracks are. So the live edge plow actually gets down into that divot area, so it's able to actually remove the snow from these irregular areas on our roads that a rigid blade is not able to do. So what that allows for is a cleaner, clearer road, and that results in less salt actually having to be applied to that road. So you get a better road in terms of drivability and less salt needing to be used. And this is a technology that's being applied in the Lake George Basin, and also most recently, the village of Lake Placid purchased a live edge plow and is using it within their village. So it's a technology and a lot more folks are talking about purchasing some version of a live edge plow to use on their trucks. Second is salt brine. Who's heard of salt brine? Everybody? Who uses salt brine? Some folks. Good. So very simple, right? So we're taking salt, we're dissolving it in water to make a brine. Here's a big machine to mix the salt up, and then it gets put in a tank. It gets applied to the roads, and the idea here is anti-icing. It's great. You have nozzles. You spray it out. You're able to regulate the flow. It sticks to the road versus bouncing off the road. You get a good coating, and it can be very effective. And the folks that use it report anywhere from a 20-40% reduction in actual salt use. So that's good. But also getting a good road treatment. Problems are concerns about effectiveness at lower temperatures. So some folks report that it's not effective below 15 degrees Fahrenheit. Whether or not that's true or not, I can't find. There's not a lot of literature sometimes on these things. But effectiveness is certainly a concern, and certainly there's an investment, right? So you have to buy this equipment to go to brine. But there's a lot of talk, a lot of interest in adding brining to the toolkit, right, for winter road management. And this is happening within the Lake George Basin. This is a county? Is it a town truck? Village truck. Village of Lake George truck applying brine. You can see that off the back of the truck. And so there's also up in the Lake Placid area, there's discussions about purchasing one of these units. The idea is you have a brine machine that's centrally located to make brine, and folks can come and fill their tanks and use the brine, and kind of co-op approach, if you will, to deal with the costs, share the cost of of this piece of equipment. So brine. And the last thing I want to touch on is this concept of optimization. And here we're talking about calibrating your equipment, actually measuring what you're doing, in our case, what you're putting down in terms of salt, evaluating the effectiveness of your treatments, and then adapting. And this is classic management cycle for anything, right? So measure, evaluate, adapt, repeat. But we're just applying the concept of salting. So we're going down through the steps, and then we're going back through, and over time we're going to develop an optimization for this particular activity, in our case salting. So beginning with calibration, so calibrating your spreaders, and then we have measurement, and here this is again coming from Lake George, where the spreader is actually, the amount of salt being applied by the spreader is measured. So they know exactly how much salt is coming out after calibration, and that's actually tied to a GPS unit. So in real time, they know how much is coming out and where it's coming out, and they can actually map the loading of salt onto the roadways in the Lake George Basin. And then, following on that, they be able to evaluate effectiveness with a series of strategically placed cameras. So we're taking pictures periodically to see the condition of the roadway. You know when the trucks have gone over, what they've done, and you're able to correlate the performance of the result in terms of what you see in the picture with what was done. And over time, you're able to optimize the application of salt to receive the conditions that you're looking for. And so what Lake George is doing is they have 20 trucks equipped with the technology, so measuring what's coming out the back, GPS unit, and then they have cameras, so 20 trucks, 8 municipalities, and they're measuring the applications of salt, treated salt, and sand and salt combined. And so again, they're able to generate maps of where the trucks are going, how often they're going there. They can compare operators, so operator A versus operator B under similar conditions. Are they applying similar loads of salt or not? So they, over time, they'll optimize the treatment. So that's the idea there. But it takes a few years, right, to be able to get this. So a word on abrasives. So here's non-abrasives, right? So this is salting our roads, and when I'm driving, when I see this condition, I'm like, oh, good, I can keep driving. So certainly it's a nice condition for driving your car at whatever speed you desire, but there's a great cause for concern, as Stuart already mentioned, as I've mentioned a little bit. So there is a movement at the local level to actually stop salting and moving back to sand. And so here's an example. This is Mirror Lake. This is the Mirror Lake watershed in New York, not the Mirror Lake watershed in New Hampshire. This one's developed, right? The other one's not. So here's Mirror Lake. That's the village of Lake Placid. Here's Mirror Lake Drive, goes around the lake. And so the village has stopped sanding, or stopped salting this road. They have a live edge plow now, and they're actually just plowing and sanding it. So they're actually, the village managers say, his commitment is, well, I'm not using salt anymore in the village of Lake Placid. I'm just gonna plow, and I'm gonna use a little bit of sand. That's his commitment for what he has control over. So and this is something you're seeing more and more of. So this is one picture, but a lot of discussions within our local municipalities of moving off the salt and back to sand. Certainly sand mixed with salt, some salt, right? But getting away from the more pure salt and going back to abrasive, which is interesting, because that was what was done most commonly back before 1980, certainly in the Adirondacks. One last thing at the local level is sidewalks and parking lots. Certainly not super common in a lot of the Adirondacks, but Lake Placid is very common. A remarkable amount of salt gets put down. When you're out there with your bucket throwing salt down, you're not calibrated, right? You can put lots of salt down in a hurry. So in the village of Lake Placid, the All Sable River Association, which is down there, has done some estimates based on the road lengths of different types, state and local, based on interviewing applicators. Interviewing applicators. About half the salt load to Mirror Lake is coming from sidewalks and parking lots. So if that is ignored, in trying to manage the roads or the salt load to Mirror Lake, that it will be unsuccessful, right? So that's important, and so what they're doing there is really a lot of outreach. All right, so regional, I got to go through this pretty quickly. So we're doing a lot of monitoring. So we have our surface water and groundwater monitoring network through the Watershed Institute. We've held several salt forums like this. It's building awareness, identifying opportunities, establishing collaborations is very, very, very important for this. We've had 3 at Paul Smith. There's been 3 in Lake George. Lake George one will continue annually, I believe. So these have been very valuable. We've established a working group which has the goal of reducing chloride in our waters while maintaining safety. And then we're working on establishing no or low salt zones. So a little bit about our working group. So this group has been in existence for 5 years. We have local government, so we actually have a town supervisor who's also the chair of the Essex County Board of Supervisors, very well connected politically, which is important if you want to work on this issue. We have environmental groups represented. We have science represented. We're engaging state agencies, so we've been to Albany a couple of times to meet with DEC, DOT to talk about salt and opportunities for action. We're coordinating, supporting initiatives. We have a salt reduction MOU, which I'll show you quickly. We have a roadmap we're creating to basically be a handout, a resource. And we're conducting studies. Stuart mentioned the drinking water study here. We're actually wrapping up a very similar study in the Adirondacks. And we're also looking at vehicle infrastructure cost studies as well. We have an MOU, which is modeled after one developed in Lake George. But you can see, so we're bringing this to municipalities starting very soon, asking them to recognize the adverse impacts, commit to reducing road salt use, adopt best management practices, reduce or eliminate salt use near surface waters, and to participate in a meeting where we're going to get together and collaborate and discuss, etc. And most of the municipalities in the Lake George Basin signed on to a similar type of menu, and we're going to, or MOU, and we're doing the same thing, trying to do the same thing in the park. Roadmap, I think I'll skip this one because I want to end on something else. So we're interested in reducing the impacts regionally. We know that if we think about the red roads, the salt is applied fairly evenly over that network. Is there anything we can do do we have any knowledge in place that we can use to decide where we might want to use less salt? I gotcha, thanks. And so I want to bring in this concept of critical source areas. So here, are there areas in the landscape that contribute disproportionately higher levels of pollution or salt relative to other areas? So if we can identify those areas and treat them differently, we may be able to have an impact on the larger area without having to treat the larger area. So identifying critical source areas, what we do is look at our data set. We're looking at the variation in chloride explained by roads as a function of how far the roads are from the shore. And you can see that we top out at about 85% of the variation in chloride concentration that is explained by roads out to about 3,000 feet. And we have this model. It's a McCallis-Menten, if you care to know. But so we developed a prediction equation where we can look at the relationship between chloride concentration variation and proximity to shoreline. So I can pick a distance. So roads within 200 feet of shoreline explain 50% of the variation in chloride. So then I can apply this model to the landscape. So what I've done here is all these red areas are within 200 feet. I can zoom in and show you one there. And then we identified there's 362 road segments. One is less, the smallest one is really small. The max is 4.7 lane miles. There's a total of 141 lane miles of road within 200 feet of the shoreline of the Adirondacks. That's only 5% of the roads. Right? So easy to think about how we might treat 5% of the roads differently to have a potentially large impact on the chloride concentration in their surface waters. So this is where we would consider alternatives like no salt areas, for example. I'm going to let Mike talk about what's going on at the state level. This would be a state level collaboration, and I'm going to stop right there. All right? Thanks.
We can take one question as we
I thought you were going to give me Stuart's time. anyway. Yes, sir.
Sorry, I didn't see.
Oh, ma'am. Yep. Yeah, so what is the implication of sanding roads on freshwater ecosystems? How's that? Very good. So it's an interesting story. So there are implications. There's no free lunch, right? If you do one thing, it comes at the expense of another thing. And actually, this switch to road salt was partly brought out because of concerns with using sand. So what does sand do? Sand gets down into our water bodies and actually packs into the substrate, affects the habitat for aquatic organisms, the fishery, etc. So there are potential nutrients coming in with the sand, right? So there are several potential negatives associated with sand, just like they are with salt. So the question is, what's the lesser of two evils? Is what we're trying to struggle with, right? But it's a good point. Yes.
Have there been any studies, or will there be any studies on vehicle accidents on roads compared to usually just sanding, or roads using sand and salt?
We haven't been able to find any studies but we would be doing studies certainly.
In Cornell local roads, about 2 years ago, a speaker was starting to talk about how the municipalities have moved large volumes of water quickly off the roads and deposited them in what would be typically a wetland and really overwhelmed those areas. And I was getting the sense they were looking to backtrack and possibly slow the water down or keep it within the area or regions.
Yeah.
Has any of that, would that concentrate the
So you're
salt?
talking about building
obviously?
like little impoundments to concentrate the runoff? Yeah, and that's something that's being discussed actually. So we would identify sort of in this concept of critical source areas, identifying places where you might build these impoundments to collect runoff that would otherwise be going into surface water. So that's an item of discussion.